What if I told you the next generation of cruise missiles could cost just a tenth of what we pay today? That's no sci-fi pitch. Lockheed CMMTD and CMMTX prototypes are rewriting the price tag, dropping costs from 1.5 million for a JASSM to 150 zero. Now, you might be thinking, how do they pull this off without sacrificing performance? The secret lies in modular payloads. Think of it like building with Legos, plus digital-first design. By using digital twins, engineers can tweak, test, and iterate faster than ever before. But here's the conflict. Can these low-cost systems truly match the reliability and lethality of legacy options? Early tests via the Rapid Dragon pallet drop and traditional pylon launches say yes, yet skeptics wonder about durability under real combat stress. The resolution? Ongoing data from biannual live-fire events is putting these doubts to the test, promising a new era of affordable, scalable firepower. Let's zoom in on a powerful force multiplier. Digital, first design, a concept Lockheed borrowed from its Speed Racer drone program. Imagine designing, simulating, and even stress testing a missile in cyberspace before a single part is built. That's digital twin technology at work, a virtual clone that predicts everything from aerodynamics to heat stress. So why does this matter? Because it slashes development cycles from years to months and lets teams iterate on guidance algorithms without budget-busting flight tests. Now, some might argue, isn't this just fancy modeling? Not quite. By integrating AI-driven simulations with rapid prototyping, digital-first design transforms risk into actionable data. The upshot: the CMMT line can adapt to new threats or payloads in record time, keeping pace with adversaries who are racing to saturate the skies with cheap drones. Why does mass production of these new cruise missiles matter for the U.S. arsenal? Let me paint a scenario. In a high-intensity conflict, munition stockpiles can deplete in weeks. The Air Force, for example, has faced gaps in replenishment due to slow manufacturing and costly procurement. Enter CMMT's digital-first modular approach. It's like shifting from artisanal to assembly line production. Now, with unit costs slashed and supply chains streamlined, the U.S. can replenish its arsenal at a fraction of the previous time and cost. But here's the kicker. This isn't just about quantity. Mass production enables rapid adaptation. Swap out a seeker head or warhead as threats evolve. The challenge? Ensuring quality control at scale. Early TREX data shows defect rates dropping as digital feedback loops improve every batch. The result? A munitions ecosystem that's agile, resilient, and ready for tomorrow's fight. Let's shift gears to the Army's bold $48 billion transformation plan, known as the Army Transformation Initiative, or ATI. On paper, it's all about increasing lethality, agility, and modularity. But here's the setup. To fund new priorities, the Army's axing legacy programs like the JLTV and RCV, conflict erupts when lawmakers and communities push back. Why scrap vehicles we just started fielding? Senator Collins, for instance, lambasted the RCV cancellation, arguing it undermines anti-drone strategy. Meanwhile, Senator Baldwin warns of economic fallout in Wisconsin. The resolution, or at least the next act, is the Army's promise to deliver detailed blueprints and second-order impact analysis. But trust isn't automatic. Congress wants receipts, and 2026 budget battles loom. ATI's fate may hinge on how convincingly leaders can show that new tech really does outmatch the old. Transparency isn't just a buzzword, it's now a battlefield. With the ATI and other reforms, Congress is demanding to see the analysis behind every big bet. Senator McConnell's words echo, "We want to see the analysis behind the bets." Why the sudden pressure? Well, abrupt program cancellations hit local economies and defense jobs, causing ripple effects across supply chains. And with legal challenges on the horizon, lawmakers want detailed second-order impact studies, essentially a forecast of every domino that could fall. Here's where technical terms like impact analysis and inter-service coordination come in. If the Army can't prove new programs won't leave gaps, or worse, trigger inter-service friction, expect more hearings and more gridlock. So, the conflict is clear. Innovation needs speed, but Congress demands caution. The resolution? It'll take unprecedented transparency to unlock the funding gates. Imagine a military innovation contest, but with live ammunition and real-world stakes. That's the essence of the Pentagon's Technology Readiness Experimentation, or TREX, program. It's not just a rebrand of the old Rapid Defense Experimentation Reserve, it's a whole new model for bringing prototypes to the field. Here's the setup. Twice a year, the Pentagon's courtyard transforms into a tech showcase with 18 autonomous systems strutting their stuff under the watchful eyes of decision-makers. The technical backbone? Biannual live-fire trials and an open-access pipeline for startups and non-traditional vendors. Conflict arises because this bypasses traditional, slow-moving procurement, the same pathways that kept disruptive tech out for years. The resolution? TREX has already cut bureaucratic red tape, letting combat units directly procure and deploy what works, not just what's approved. The result? Faster, smarter, more agile warfighting capabilities. Let me tell you a story about David and Goliath. Only this time, David is a tech startup. Thanks to TREX's open access approach, small businesses and regional suppliers are entering the defense innovation arena. Historically, procurement favored giant contractors with long track records, but with initiatives like Blue, UAS, and Replicator, even a 5-person drone shop can compete for Pentagon contracts. The technical terms here? Open architecture and rapid prototyping. Think of open architecture as building with universal connectors. You can swap parts, software, or payloads without proprietary lock-in. Some skeptics might ask, won't this flood the field with unproven tech? Fair question. TREX answers by requiring live-fire validation, ensuring only the most reliable systems make it through. The upshot: new ideas rise faster, while risk is controlled through rigorous, data-driven trials. Now you might be wondering, with all these new missiles and drones, who's really in charge? The answer isn't always clear, and that's where inter-service friction comes in. The Army, Air Force, and Navy each have unique needs, but when programs like ATI and TREX cross boundaries, lines blur. Take multi-domain operations and decentralized procurement, two buzzwords that can mean collaboration or chaos. For example, if the Army cancels a vehicle the Air Force counted on for base defense, gaps emerge. Or, when TREX empowers field units to buy directly, it can spark turf wars over budgets and priorities. The conflict is real. Coordination must keep pace with innovation, or risk duplication and wasted resources. The Pentagon's challenge is to set clear protocols and joint goals, resolving friction before it turns into dysfunction. Otherwise, the promise of speed could backfire into confusion. Behind every canceled program lurks a legal minefield. Think about it. When the Army axes legacy vehicles, contractors and local governments may sue to recover sunk costs or lost revenue. Legal challenges and industrial base vulnerability aren't just terms for policy wonks, they're the reality facing thousands of jobs and entire communities. Now, you might ask, is innovation worth the risk? It depends on how the Pentagon manages transitions. Too abrupt, and suppliers fold. Too slow, and the U.S. falls behind adversaries. The resolution? Some propose phased transitions, with incentives for retraining and retooling. Meanwhile, supply chain shocks, like sudden demand for new missile components, can ripple worldwide. Policymakers must weigh speed against stability, and that balancing act will define whether transformation succeeds or stumbles. As we look ahead, the convergence of low-cost cruise missiles, agile procurement, and autonomous systems is reshaping the U.S. military's playbook. The mission is clear: modernize for speed, scale, and affordability. But how do objectives like replenish munitions stockpile and accelerate drone deployment translate into battlefield advantage? The answer lies in strategy. Using digital design and open systems to stay ahead of adversaries, and tactics like Top Gun-style drone trials to validate what works. The final act is still unwritten. Will Congress unlock full funding, or will budget gridlock slow progress? Will the industrial base adapt or fracture under pressure? One thing's certain: the winners in tomorrow's conflict will be those who master agility and autonomy, turning innovation into real-world combat readiness. The future is on a countdown, and the clock is ticking.